Good evening, everyone, and welcome to another episode of Starstream by Focus Astronomy. Tonight, we're going to be checking out all kinds of cool new targets that we probably didn't get to last week, and we're going to visit some new favorites as well. But we're going to try something different this week, and hopefully, we can apply this moving forward on all the star streams. And we're going to take basically a overview of what's up in the nighttime sky right now, a digital star tour, if you will. So that way we can get acquainted with everything that we're going to be looking up at this evening. And we're also going to go over some terminology, so it'll make it easier for those who are new to astronomy, might not understand, so that way as we progress through the evening, you can understand some of the terminology that we're going to be using throughout the night as we describe some of these targets. So let's take a look at what we're looking at outside at the moment. And I will pull that up right here. And so what we have right now outside is called an all-sky camera. Let me get this going for us really quickly. Just bear with me. There we go. All right. Pop this over here. So this is an all-sky camera. This is basically what we use to see what's up in the nighttime sky. Let me get out of the way here. That'd probably be helpful, wouldn't it? Scoot over. Boop. This is an all-sky camera. And this is basically a this particular one is black and white. And this actually lets us take a view at what's going on outside without actually being there. We actually use these for remote observatories. So if we're working on a telescope that we can't be anywhere near, then we have the all-sky cameras to basically take a look at everything we're looking out at the site if we can't be there. So this is live, and this just gives you an idea of what the night sky is right now. It is a little windy outside, so we're going to try to play around with this a little bit. But this just gives you an idea of regular backyard, not a great light, a pretty heavily light polluted sky, but there's still a fair amount of stuff that we can actually see even from where we're at. For instance, you can see the Big Dippers right over here. You can kind of make it out right there. This bright, weird-looking thing over here, it's not a UFO, so we're not even going to start there. That's the planet Venus. It's just getting towards a weird spot in the lens, so it kind of warps it. And then we have some other bright objects up in the nighttime sky as well, and some of the constellations we're going to cover here. So that is our all-sky camera that lets us see what's going on out there. It's actually taking pictures of everything right now. But we're going to try to get a little better view real quick. Let me switch over to our Planetarium software. Now, this software that we're using right now is called Stellarium. And Stellarium is actually a free software you can download online, and you can move it all around the night sky, or all around the sky. And it's a cool way to navigate and play around with things. So we're going to try this and get acquainted with the sky and understand what constellations we're going to be looking at and what we're going to be working in throughout the evening. And that way we become a little bit more acquainted with everything, so we're not just kind of shooting in the dark at that point. Get some of this stuff out of the way. So let's get the constellations on here so we can actually see it. All right, so we are officially in spring. Winter is over. It ended March 21st, I think, was the spring equinox. And all of that is setting over here in the west right here. So this is all setting over here in the west. Now everything over here is in the east. So everything rises in the east and sets in the west. And it all pivots around the North Star Polaris, which is right up here. In the northern hemisphere, this is what marks the northern position. And all of that, as you can see, rises in the east and sets over here in the west. And everything pivots around that star. So let's pause that and go back to where we're at. So everything pivots around Polaris. Now, we kind of fast forwarded a little bit. Let's try to go back to where we actually are really quick. A little too far. Yeah, right about there, at 8 o'clock. So all these constellations, if you're in the northern hemisphere, you should be able to see in your backyard. You can go out right now as long as it's clear. And you should be able to see the constellations to some extent. Obviously, the software's got a little bit better. So let's take a look at what's up tonight. So, like I said, we are officially in spring. All the wintertime objects are pretty much coming to an end, and now we're getting all of the springtime objects. Now, the first one, of course, the most popular is Orion. And Orion, turn this on real quick. Shoot this up. Now, Orion is actually the main wintertime constellation that we see right here. And let's scoot this over right about here. So this is Orion, right inside the box there. This is the constellation of Orion. And Orion can easily be made out because it's got a couple bright stars. We've got Betelgeuse, and everything came after Betelgeuse. Obviously, the characters, you say the name 3 times, that was not first. Betelgeuse also means armpit of the Great One, which is actually right in the arm of where Orion has his upper arm and the rest of the body. And then obviously down here we have Rigel. Now, interesting thing, Betelgeuse is a super red giant. Rigel is a blue giant. So you get 2 contrasting types of stars there. And then, of course, we have the belt stars, which are the most recognizable of Orion. You have Alnitak, Alnilam, and Mintaka. Now, what's kind of neat about Orion is that we can take a look at this from here on Earth, and it looks like it's one cohesive constellation. And it's not. All the stars are varying distances. And this is where I'm going to talk about a little bit of the distances that we're talking about. Now, for some of the new attendees here who might not be familiar with some of the astronomy terms, you're going to hear light year a lot this evening. A light year is the distance light travels in the course of 1 year, which is about 6 trillion miles. It's about 186,000 miles per second. And that's, roughly on average. So a light year. And when you hear an object is so many light years away, it has taken the light that long to transition from that object to your eye or the telescope. So to get that example started, let's take a look right here at Betelgeuse. Betelgeuse, you can actually go outside right now and take a look at that. That is the bright orange star in Orion. That is 500 light years away, which means the light you're seeing left that star 500 years ago, and it's just now getting to us. Even going 186,000 miles per second, it still takes 500 years to get here. Now, if we flip over to the other side of the constellation, we have Rigel. And Rigel's getting a little low because everything is setting for the wintertime. Rigel is actually 860 light years away. So even though they're part of the same constellation, they're vastly different distances from each other. And that also goes for the belt stars. For example, Alnitak right here, we'll scoot in here, the belt stars. Alnitak right here is about 740 light years away from the Earth. Mintaka is actually the closest of the three at 690 light years away. And then Alnitak in the middle there is actually 2,000 light years away. So while they do look like one cohesive little bunch, get it in my square here. There we go. While those three belt stars look like one cohesive set of stars, they are actually quite different from each other in distances. So it gives you all, it's all about perspective. So from our perspective, it looks like they're all together, but they're actually not. So kind of interesting. Let's move over to our next constellation real quick. This is a little bit higher, kind of the last one of the wintertime constellations, and get that in the square. And that is Gemini, the Twins. Now, Gemini is actually marked by the two brightest stars in the constellation, which is in right here. Now, the first one, of course, is Castor. Now, Castor is 51 light years away from us. And what's interesting about Castor is that it's, while to our naked eye it looks like one star. Let me scoot in. Let's center this up real quick. To our naked eye, it looks like one star. To some amateur telescopes, it'll actually split because it's a multi-star system. But it actually has been confirmed to be 6 stars. It's 2 triplets of stars, and they're all actively orbiting with each other. So really advanced system right there, star system. And that's 51 light years away. So if you're 51 years old, or you know anybody who's 51 years old, the light left this star system the year they were born, just to give you an example. So it takes 51 years to transition from this star to Earth, and that's going 186,000 miles per second. Now let's jump over to the other twin, Pollux, which is right here. These are all visible outside right now, so you could go out and check all this out if you wanted to. But this is Pollux. This is the other twin. This is 34 light years from Earth. And this has actually been confirmed to have planets orbiting around it as well. Extrasolar planets are confirmed to be around Pollux. And this is 34 light years away. The light we see from this star left 34 years ago. And that is the constellation of Gemini, the twins. So we did Orion, we did Gemini, and we did the belt stars. Some other popular ones we're going to be working in tonight, of course, is Canis Major, the large dog, which can be found by Sirius. And Sirius is the brightest star in the sky, and yes, I'm absolutely serious about that. This is about 8.5 light years away, so a little bit closer. If you've ever wondered where Sirius Satellite Radio got their name from, as well as their logo, because it is a dog, as we can see right here, the dog. That is the large dog. That's where Sirius Satellite Radio got their name from. Or if you're into Harry Potter, that is Sirius Black. The direction we're looking in right now is southwest. All the markers are down here. I was cutting them off a little bit. But if you look at the bottom of the screen in red, right now we're in the west. And for Canis Minor over here, we're in the southwest. Gemini is almost not quite overhead, and then you can still catch the planet Venus out there real bright in the western sky. It'll be the brightest object in the western sky right now, and that's the planet Venus. Now, okay, so, and Venus is in Taurus the Bull, but Taurus is getting pretty low, so it's hard to see a lot of its structure. But all that is in the west and the southwest, currently setting. Gemini is nice and overhead right now. We have the constellation of Cancer the Crab. This one's a little bit more difficult. It's only made up of 6 stars. So, though there is a very nice cluster in there called the Beehive Cluster right there. And maybe we can check that out in the telescope tonight as well. A couple more constellations real quick. The next one right here I'll put in the square. This is Leo the Lion. Leo can easily be seen, and this is practically straight overhead right now, almost overhead. Leo the Lion can be found by finding the backwards question mark, which you can see right here. And the punctuation mark down here is Regulus, which is the brightest star in Leo. But look for the backwards question mark and then kind of the boxy body. And that is the constellation of Leo, the lion. And this is where a lot of, over the next several weeks, as we zoom out here, the next several weeks, we do these live streams. We're going to be working up in the constellations of Leo, Leo Minor, Coma Berenices, Virgo, or Virgo is over here, sorry, Virgo. We'll get a little bit into Buddhists later. And then, of course, Ursa Major, more well known as the Big Dipper. The Big Dipper is actually what's called an asterism. And an asterism is just a collection of stars that kind of make up an image. It is not actually the whole constellation. The whole constellation would be Ursa Major, the large bear, and then the Big Dipper, as well as the Little Dipper, are all known as asterisms. So that's pretty much it for our look at the night sky. Just some basic stuff. There's a ton of constellations. There's actually 88 constellations in the entire night sky, including the southern hemisphere. That's actually the same amount of same number of keys on a piano, 88. So 88 keys, 88 constellations. So something fun for tonight. Let me turn off our square here. And again, this software, if you want to check it out, this is Stellarium. It's free, and you can pick this up online. So now that we're kind of acquainted with the night sky, we're going to switch over to the telescope itself. So let me pull this out of here. We're going to get rid of that. Pop everything in there. So now that you've seen everything on the Planetarium software, you can actually see, kind of get more familiar with the all-sky camera on what we're working with right now. There's the Big Dipper rising over there. This is Polaris, should be just right down here above the tree. And then we've got Orion, got an airplane over here. I think that's an airplane, could be a satellite. And then the rest of our sky. So we'll get rid of this. And we're going to switch over to the telescope. So I have a collection of targets tonight, but if there is something you want to see that I have not covered, you can always write over in the live chat, and we can take a look at that throughout the evening. The telescope's fully robotic. We can move it around and check all that out. Tonight we're actually using a Skywatcher Esprit 150 triplet refractor. So it's a 6-inch refractor. And it has a Starizona Apex EDL reducer in there. And so we're running the telescope at f4.5 for all of my astronomy peoples here. So running pretty fast. And then we're running with a Starlight Express 694 monochrome camera with a 7-position filter wheel on board. And we can flip through all different kinds of filters to view different wavelengths of light. And but to get started, before we lose it, it might be a little close. We're going to do, obviously, the fan favorite, which is Orion. So let's get the camera going and run over here. Now, the first thing we're going to do here is we're going to actually, to keep some of the light pollution out, we're going to flip the hydrogen alpha filter into the mix. And for those of you who don't know, a hydrogen alpha filter, if you look at the visible spectrum of where our eye can see, way over in the blue is ultraviolet, and way over in the red is infrared, and stretches beyond that. Now, we have filters that can isolate wavelengths of light, and some of those filters can help isolate some of the light that's emitted by certain objects. So the Orion Nebula is what's known as an emission nebula, which means it emits its own light. The stars inside the core there, known as the trapezium, light up and excite the gas and cause them to emit their own light. And they actually emit light in what's called frequency in the red part of the spectrum, and this is known as hydrogen alpha. and what's way over in the red part of the spectrum. So this is Orion in hydrogen. The filter's cutting out everything else except this particular band of light. We are shooting relatively low in the sky, so things are a little bit soft, and it's also really windy out there tonight, so the scope's kind of fighting with everything at the moment. But this is the Orion Nebula. This is live off the telescope. The exposures that you see over here, this is the camera taking a picture. Each picture is 15 seconds long, so it's open for 15 seconds. And then we are using a black and white camera because they are more sensitive than color cameras, and it lets us more of the details in there. So this is the Orion Nebula, originally discovered in 1610. It's 1,600 light years away from the Earth, and it sits just below the belt of Orion, those 3 stars in a row, just below there in what's called the sword of Orion. And this is a star-forming region, or a stellar nursery, which means the dust in there is condensing down, making new stars. So this is a stellar nursery, also known an emission nebula. And actually, I have my little ball. So if you have our nebula floating out in space, that nebula is condensing down to make new stars, new solar systems, and a bunch of stuff like that. So all kinds of cool stuff to see. Now, deep down in here, let's see if we can bring this down a bit and zoom in a bit. So right in the center here, let's bring our handy dandy square back up here. There we go. Right in the center there. It's hard to see because everything's really windy tonight. If it was a little calmer, then it'd be easier to point these out. But this is the trapezium. And the trapezium is a collection of stars that's mainly lighting up a lot of those details that we're seeing. The nebula, basically. It's emitting the light, exciting the gas, and causing that whole cloud to basically glow, much like a neon sign. So that is the trapezium. And that gets overshadowed in a lot of pictures because the nebula gets so bright. So if we bring the exposure back up, we lose that real quick. And we can zoom out here. There we go. Back to full frame. And we can see the nebula hanging out there with some of the extensions and coming off the edge. This section right here, this is known as M42, which is technically the Orion Nebula. And then this little ball section down here, spherical section, that's called M43. And the M stands for Messier, for Charles Messier, who was a famous comet hunter way back in the 1700s. And he was looking for comets, and he ran across a bunch of targets that he thought were comets, and he documented them. And that's how we've come to know the Messier catalog of objects. And this is Messier 42 and 43. And that is the Orion Nebula. And this is setting right now, so we're not in a prime location to check this one out. We'll have to wait till next year in the wintertime, or later this year, around December, when we really get another chance to see this, because we are at the end of the season. So that wraps this target up. We're going to pull up stakes here, and we're going to switch over to a next door neighbor of this object. This one's a favorite of mine and probably a lot of astrophotographers, but it's right across the street, essentially. We'll get the camera going. And we're going to stick with our hydrogen filter because this is another nebula. And this one actually needs the filter to really come out to be visible, because it's practically invisible from town without the aid of cameras and these specialized filters. So we'll give this a second to pop up, and we'll get a good shot of this nearby nebula. So this particular nebula is the Horsehead Nebula, and the Horsehead Nebula is located obviously in the constellation of Orion. It's actually in the belt, and this bright star right over here, that is the bright star Alnitak. which we talked about a little bit earlier. So the bright belt star, this is 740 light years from Earth, but the actual Horsehead region, it can actually vary depending on what you read. There's 1500 light years to 800 light years. I've seen both. But let's try to stretch this a little bit. The Horsehead Nebula is actually composed of two sections. The grayish area you see back here, that is what's known as IC 434. It's another emission nebula similar to Orion. And the center part right here, the actual Horsehead itself, which looks like a black thumbprint right there in the center, that is known as B as in boy 33, or Barnard 33, which was actually named after E. Barnard, who is a famous astronomer that did photographic surveys of the nighttime sky with glass plates. It was a 10-inch telescope and glass plates, and he discovered a lot of these, what are known as dark nebula, which are cataloged as the Barnard objects at this point. So this is B33, the 33rd addition to that catalog. And this is the Horsehead Nebula. This is also really low. You really need a big telescope in dark skies to actually see this visually, about a 16-inch telescope and really good skies, and the aid of an H-beta filter. So that is the Horsehead Nebula in the constellation of Orion. Ernie, yeah, we can go check out the Rosette Nebula. We've got time for that. Let me make this go away. And let's get this loaded in the system here. We're going to stop our exposures again. And we're going to fling over to the Rosette Nebula, which is not far. Actually, that's perfect. It's not far from our next set of objects. So we're going to fling the scope over there, get our camera going again. Because this is going to be a nebula, we're going to keep the hydrogen alpha filter in the view. And so the Rosette Nebula is a huge nebula. And it's actually composed of a star cluster and a nebula at the same time. And this is in the constellation of Monoceros. It's 5,200 light years away, and about 65 light years radius of that. So let's try to pull this out. Again, it's real cloudy out there. Not cloudy, it's really windy tonight, so it's kind of pushing the scope around, but you can start to see the structures kind of coming out. The telescope is actually cannot fit this in the field of view. It's just too big. It's a huge star or section in there. So this is the Rosette Nebula, also known as Caldwell 49 is one of its catalogs, but there is a multitude of NGC numbers going off of different parts of the nebula. So there's NGC 2237, NGC 2238, NGC 2239, and then the open cluster in the center there is NGC 2244, and then another part of the region there is NGC 2246. So that is the Rosette Nebula, while huge, is made up of a variety of different targets, objects built in all together there, and that's about 5,200 light years away and about 130 light years in diameter. So that is the Rosette Nebula that we're kind of fighting to pull out at the moment. So this is a great object to do photographically, and you can see this in dark skies with the aid of a telescope and an oxygen 3 filter, or O3 filter as they're known. If you want to try and take a view at it, take a look at it if you have a chance in dark skies. So moving forward, so that's the Rosette Nebula, and I think that puts us in a good position to hit another object not too far from here, but this is going to require a slightly different filter. So let's get on over there. This is a fun one for people who do outreach, and surprisingly, it gets overshadowed quite a bit, mainly because it's in the constellation of Orion, and of course we all know that Orion is very, very popular. Damien the Eta Carina Nebula, as much as I'd like to see, is too low for us here in Arizona. We have to go a little bit further south. So let's switch here. So we're on the target here. Okay. Let me get back into the camera. And this is a star cluster that we're looking at. It's called NGC 2169. And because it's a star cluster, we don't need that nebula filter. The hydrogen filter is not needed anymore. So we can flip to visible. So the light that we're going to be shooting in now is visible light. It's letting all the light come in that particular color. This is the green filter, which means it's passing the green frequencies of light, which is where the human eye actually peaks. So what you see in here will be very similar to what you could visibly see in a telescope in a dark sky. So this is NGC 2169 in the constellation of Orion, and this is one of my personal favorites. This is what we call the 37 cluster. And the 37 cluster, which you can see right here, turn this on, boop. We can also zoom in here. The 37 cluster is kind of fun because it actually looks like the number 37. And you can see the 3 right here and the 7 right there. And that is NGC 2169. It's in the upper arm of Orion. It's actually relatively easy to see in a 6 to 8 inch telescope, and if you have a Newtonian telescope, it actually flips it because of the mirror image and actually orients it the right way that you'd want to see that. So again, this is NGC 2169 up in the constellation of Orion. Relatively easy to see for anybody who wants to get a telescope out and check it out. This was originally documented to be discovered in 1654, but it wasn't actually confirmed until 1784. I'm sorry, 1654 originally, and then documented officially in 1784. And this is NGC 2169, also known as the 37 cluster, and that is an open cluster. There are 2 types of clusters in the nighttime sky, open clusters and globular clusters, which are dense balls of stars. And we'll get to the other type of cluster later this evening. So again, this is NGC 2169, the 37 cluster, 3,600 light years away. So the light we're seeing from this cluster left there 3,600 years ago, and it's just now getting here. And so that is a fun one. Now there's another object not too far away from here. I really enjoy these types of targets, and I'm gonna make our little box disappear. And we're gonna stop our stuff here. See what's going on here. There we go. We're going to stop and go over to our next target, which is actually not that far from us at the moment. Yeah, John, let's go do the flame. Before we run over to this object we were just going to go to, we're going to sling back down to right near the Horsehead Nebula, but we're going to go right next door to the Horsehead and do the Flame Nebula. The Flame Nebula is another cool nebula. It's actually more visible than its Horsehead counterpart. So let's see if we can get it. We'll flip back to the hydrogen filter. I know a lot of you are seeing me flip through the filters. On the back of the telescope, we use a variety of different filters, and this particular one has 7 filters on board. And they live in a wheel that has a little carousel, so rather than me going out there and flipping filters, we just press a button and it rotates that filter into the position and keeps them nice and clean. So we've flipped back to the hydrogen filter, so we're isolating that wavelength of light where hydrogen emits light. And we're looking for the Flame Nebula. We're going to stretch this a little bit, and you can start to see it come out right here. And this is the Flame Nebula. It's just off of the Horsehead. This is Alnitak again, and the Horsehead section is right over here. So we're not far, right next door actually. This is 1,350 light years away from the Earth. It is 6 light years in radius, so it's 12 light years in diameter. And this is another hydrogen, cloud of hydrogen floating out in space right there. Most of the nebulas, because hydrogen is so abundant in space, this is why you see a lot of hydrogen floating out in space, because there's a lot of it. Most of it's made up of hydrogen. So that's why when we use the hydrogen alpha filter, those are so bright and detailed, because there's just so much frequency that the camera can pick up. So this is just at the bottom of the belt of Orion. This is the bright star Alnitak again, the bottom star of the belt, and the Horsehead is right over here. So that is the that is the Flame Nebula, right next to its companion, the Horsehead Nebula. About somewhere between 900 and 1,300 light years away from the Earth. So good call, John. We'll stop this real quick, and we're already positioned to go to our next target anyway, because we are in that section of sky. We've got the right filter loaded in there. Now we just need to make our way over to it. Let me just tell the telescope to fling over here real quick. There we go. Flew over there. This is also, we're trying to hit everything in the wintertime stuff before we lose too many of them early on. So let's get the camera on here. There we go. And let's start shooting that target. So, Ernie, I'll see if I can get over to M35 here in a second. And we'll try to see if we can hit that one. That should be in a decent position for the time being. So let's get this one done first. Oh, this was not the nebula I wanted. So hold on just a sec. Let me get the telescope onto the part of the sky that we want it to be in. Let's see. Because this is actually a cool object as well. So let me get it on target here. Okay, there we go. Not quite in the right position. There we go. Now we're in the right position. Now we'll get back to the camera. We have the right filter in. We are shooting a nebula again. And this is, I really like these nebulas, and it's not going to look like much. It's actually going to look like a reflection, but it is in fact a nebula. And that's going to come up here in just a second. All right, so this right here is our star field. And if you look closely, let me bring up my little box once again. We're going to squeeze it down a bit. Get my box up there. There we go. So right in the center there, you're going to see a bright star. And that bright star is Mu Orionis. It's actually naked eye visible. And it's up in the upper arm of Orion. But you see this little fuzzball next to it. That may look like a reflection off the filter, but that is in fact a nebula. That is a planetary nebula. And due to the wind and everything out there, this is not nearly as sharp as this telescope can produce that image, but you know, we're dealing with it tonight. This is called Abell 12. Abell 12 in the constellation of Orion. This is a planetary nebula. So originally we started out with a star like our sun, and eventually that star starts to shed off its outer layers as it gets older and older, forming a planetary nebula and leaving nothing but its little core, leftover core known as a white dwarf in the center of that nebula. And that's what we get afterwards, is a little puffed out cloud known as a planetary nebula. Now this should be a lot sharper if the seeing conditions outside were more stable, but at least you can see the little glow there, and that is about 6,900 light years away from the Earth, and my guess is it's probably about a light year in diameter. These Abell planetary nebulas, there's 86 of them, and these were originally cataloged by George Abell in the early to mid 1950s. They were doing a survey of the night sky at the Palomar Observatory in Southern California, just outside of San Diego, with a 48-inch telescope and using glass plates, and they were documenting the night sky. And during that survey, they found some of these nebulas, these little planetary nebulas, and some of them are not planetaries in the catalog, but they found 86 nebulas. And this is what's come to be known as the Abell planetaries. And this is entry number 12 right there. You need a fairly big telescope, about 16-inch in diameter, to catch this one visually, but it's kind of a fun one because it's right off the bright star of Mu Orion. And it's a challenging target for people to come check out. So that is Abell 12 in the constellation of Orion. We're going to stop this real quick. We're going to move to our next target before it gets a little low. Let me flip over to the telescope right here. Now, a lot of people have been watching for Comet Atlas. It's been kind of a target of interest lately because it's a fairly bright comet, or was supposed to be a fairly bright comet, and it still is. I think it's just inside the visual limitations of what the human eye can get in the best skies, and but it's starting to break apart right now, and at this point we want to catch it before it goes too dim. So Comet Atlas, or C2019Y4, was the last comet found in 2019. It was found by the Atlas Sky Survey in Mauna Loa, Hawaii, and this was the last comet found for the year. And that particular survey out in Hawaii is they're looking for asteroids and stuff like that, so they just happened to come across the comet. This was supposed to have its closest approach May 23rd, but now as it's getting closer to the sun, it's starting to fall apart. So we checked this out last time, and we were able to make it out in the telescope. So we're gonna try and get it right now and see what we can pull out from it. And let's see if I can fix some of my stream settings real quick, because I know things are a little glitchy tonight. I think that's because of the wind, but we'll try to clean this up. So right now we are on Comet Atlas. Right here, let me put up my little box again and put the square up. So right there in the center, that little diffuse little fuzzball there, that is Comet Atlas. We're just inside one AU. An AU is an astronomical unit, which is the distance between the sun and Earth, so 93 million miles. So we're just inside 93 million. It's like 0.9 astronomical units right now, and that is Comet Atlas. And it's actually starting to disintegrate. So its close approach was technically supposed to be May 23rd. We'll see if it even survives to any of that, and we'll see what we can do with that. But this is Comet Atlas. This is coming right off the telescope, and this is visible. If you had a telescope and you knew exactly where it was, you could probably pick that up. But it is a bit of a challenge right now, as it is starting to disintegrate quite a bit. And so we're catching it right now. I'm hoping we're going to be able to see more of it as we move forward. But it's not looking too good for the comet at this point, but it's there. It's not as sharp as it was a couple weeks ago, but you know, that's to be expected when your big ice cube starts to fall apart. So again, if you're just joining us, this is Comet Atlas, and this is invisible light. Right inside the box there, that is the comet, a little diffuse fuzzball. And comets are pretty much just big dirty snowballs, and that's about all they are. So they really have to try and see if we can, you know, really nail one of those before it disappears. And get a drink real quick. Lots of talking today. But anyway, that is Comet Atlas, right in the center there, just under 93 million miles away from the Earth. Now, we're going to switch targets real quick. I know I've got some requests there. I got a big list here. I just want to make sure we can catch some of these wintertime ones. I've only got a couple left on the wintertime list before we lose some of our view there. So we've got two more, and then we can maybe jump over and check out some of the other stuff. The next one up, though, is pretty neat. And it actually gets overlooked quite a bit as well. So we're not too far from it. We're going to flip back to near Orion, but not quite Orion. This is the constellation of Monoceros. Not far from Gemini and not far from the Rosette. So we're going to stick with the visible light filter. And we're going to start our exposure here real quick. Jared, I'm using SkyX to control the telescope right now, and it has a live stack feature, so all the images that you're seeing, it's actually auto stacking all of them for me. So this is SkyX Pro with the camera plug-in is what I'm using. So let me turn on my box again. You're going to see right in the middle, it looks like a little white fan, almost like a ghost. This is really small actually too, so we'll zoom in a little bit to bring it up. But this is known as Hubble's Variable Nebula. This is a really interesting nebula because it's a reflection nebula. So the light from this gas in the center there is being reflected off of that main star there. And that main star is our Monoceros. And what's really interesting about this is this material, I believe, is fanning from the star itself. And this is also known as a variable nebula, which means it varies in brightness from when you look at it. Now, Edwin Hubble, who the Hubble Space Telescope was actually named after, did several observations on this nebula between the 40s and 50s, and was able to kind of watch this thing change throughout his observations. And what they found when going back and observing with the actual Hubble Space Telescope is that there are dense clouds up towards the star as the nebula spins that are actually causing shadows to be cast on the nebula itself and block some of the nebula, causing it to be more variable. So this is Hubble's Variable Nebula, or if you want the fancy impress your friends name, this is NGC 2261 in the constellation of Monoceros. This is 2,500 light years away. The light we're seeing right now left there 2,500 years ago, and is about one light year in diameter. And this was originally observed in 1783 by William Herschel, is where the original observation was done. But yes, this is Hubble's Variable Nebula, NGC 2261. And you can catch this in an 8-inch telescope in decent skies, or pop a camera on there and shoot it from your backyard like we're doing right now. So that's kind of a cool object to check out right there, is Hubble's Variable Nebula. let's see, some requests. Damien NGC 6302 is not visible at the moment. It's below the horizon. 2419. Let me double check on that one. That one is actually up. It looks like a globular cluster. Let's see if we can hit that real quick, because we do have the right filters in there. Flip back over to the telescope controls. NGC, what are we on? 2419 is the request. Flew over there. And let's check it out. Flip the cameras on. All right, we'll get the exposure going right now. See if it'll listen to me. So NGC 2419, this is in the constellation of Lynx. This was originally discovered on December 31st, 1788. And if you're all wondering what NGC stands for, it's New General Catalog. It's kind of a master catalog, or it was a master catalog. Now there's plenty of other large catalogs out there. So this is a globular cluster, kind of a cool cluster, a little fuzzball in the center, almost looks like the comet we looked at earlier. This is, let's see, about 260 light years in diameter, which is actually a fairly good size object to be seen. And I've never observed this one personally, but globular clusters are dense balls of stars. There's about 150 of them in the Milky Way, and these 150 clusters make a halo around the core of the galaxy itself. And this is one of the fainter ones. There's several brighter ones, of course, but this is a neat one in the constellation of Lynx. You normally see these up in the summer months when we're looking at more of the summertime objects at this point. So this is NGC 2419 in the constellation of Lynx, and this is at 274,000 light years away from the Earth. So it's a little bit of a drive to get out to this object if you wanted to check it out. So again, NGC 2419. Good call, Jay. That's a good one. I'll have to come back and check that one out. So let's close up this and hit our next target. We're kind of pounding through all kinds of stuff tonight. Got some good picks. Let's see. IC 2118. Let's see, 2118. The Whirlpool Nebula. Let's see. The Whirlpool is a reflection nebula, and it is really hard to do. And the telescope we're shooting tonight is not big enough to fit it. And it's also really low. It's practically almost too low for us to get on the scope. Yeah, it's way down here by Rigel. So the witch head there, IC 2118, is a toughie. So that one I won't be able to hit tonight. It's not in a good position, and the only real way we can see it is really dark skies. But that is a cool one to try. So let me turn my little square off here, and we're gonna go ahead and pick our next target. Let's see. Oh, this one's fun. We'll try this one. We're going to do a Messier target. The Messiers are, again, from Charles Messier. These are really easy to see in pretty much any size telescope. So it's good to go check out and explore. And we're going to jump onto this one right now. This is another open cluster, but it just happens to have a surprise in it. So this is M for Messier 46. Is the 46th entry, originally discovered in 1771 by Charles Messier. This is one of his original actual discoveries for the Messier catalog. This is 5,400 light years away from the Earth, And what's cool about this one is you can see the cluster right here in the middle. So let's see. Let me make my little, here's where we're looking, square pop up. So that's the cluster right there. But what's kind of neat is you see this little bubble right here? That bubble is a planetary nebula. Now, they actually look like they're part of the same thing, but they literally have nothing to do with each other. The nebula is actually a foreground object. The cluster itself, the open cluster, and this is in the constellation of Puppis, by the way. This cluster is about 5,400 light years away from the Earth, 30 light years in diameter. The nebula that sits right here is only 2,900 light years away, so there's a pretty substantial distance gap between the two. So this again is all about perspective. So from where we're looking, they look like they're on top of each other, but they are almost several thousand light years between one another. So this is M46. The nebula is known as NGC 2438. And it's just a little tiny planetary. And you can actually see this in a decent scope, like a 10-inch. And dark skies help, but the bigger the telescope, when I had my 20-inch Dob at the time, and we were doing outreach events with that, the 20-inch really took it down. You could really see that little bubble just go boop. But that's a fun one. It's kind of a 2-for-1 object if you ever want to get out and check that out. It's still got a couple weeks left of good viewing, but we are getting to the end of it at this point. So let's see. Damien wants to check out NGC 7635, the Bubble Nebula. I love the Bubble Nebula, but it's not up at the moment. That's a fall, autumn object. So hopefully in autumn we'll be able to check that nebula out. But the bubble is pretty awesome. So let's get on to that. Let's see. Where was it? Ernie, the Thor's helmet. You actually picked the next target that we were going to on the list anyway. This is a cool one. So we're going to stop on, this is M. Messier. M is in Messier 46. And it's little, not so much a companion, but little buddy in the field there, NGC 2438, the little planetary nebula right there. And this is in the constellation of Puppis. This is a fun one you can go check out. And now we're going to move on to our next target. And this next one is not far, once again, from where we're looking. But we are going to need to flip our fancy filters into place for this one. Let me get the telescope onto it, though. This next target's called Thor's helmet. And this is a really interesting nebula. This is an emission nebula. So again, it's emitting light from being lit up by the stars inside of it. But this is a special type of nebula. So let me get the filters flipped in there and pop that in. And we're going to let the camera do its job. So this is in Canis Major, the large dog. We're not far from Sirius. And we're going to let this expose. This was originally discovered by William Herschel in 1785. It's about 12,000 light years away from the Earth, so we're getting progressively farther out. This is going to be one of the furthest objects we see tonight. It's really low at the moment, and we are shooting through a lot of city light, even though we have that filter in place. But the big problem right now is the wind. It's just making everything super turbulent. So that's why all these stars look not sharp. The scope's really fighting with it tonight. I did a test on this last night. It was pinpoint. So of course the weather tonight changed, but we're lucky that it's clear. So this is Thor's helmet. And it gets its name because you can actually see the head arc right here and then the two horns. That's where it gets its name at that point. And it's really kind of a fascinating object to check out in a telescope, and you don't really need a big telescope to see it. But this particular type of nebula is also known as a Wolf-Rayet star, or it has to do with a Wolf-Rayet star. And Wolf-Rayet stars, which I believe this is the star in particular in the middle of the helmet, are extremely hot, very luminous stars that are rapidly losing a lot of their mass because the stellar winds in that region are very quick and strong, and they're blowing a lot of the material off of that star that's already towards the end of its life. It's blowing that material off and causing that nebula to occur, and that's known as a Wolf-Rayet star. And there's several of them. This would be Wolf-Rayet 7 or WR7, and so that's a pretty interesting one to check out. And as we get into the summer months, there's a couple others of these types of objects up there. Just to give you an idea, this particular object, Wolf-Rayet 7, which is this guy in the middle there, is 280,000 times brighter than the sun, 16 times more massive, and 1.4 times larger physically than the sun. So that's a big hunk of something going on up there. And that is a Wolf-Rayet star, WOLF-RAYET. Wolf-Rayet is what that is. So pretty interesting. Let me get through some of the questions here. If Sirius is a double star and too bright to typically see the double, what type of scopes would you use? Roy, so for those of you out observing and you want to go check out Sirius, the bright star Sirius is a binary star system. It's the brightest star in the sky, but it's actually two stars. It's a very difficult double star to split as well, because Sirius A is a lot brighter than Sirius B, the little companion. So the best time to do it is actually during dusk, before it gets dark. So dark enough to where you can see Sirius, but bright enough to where the rest of the sky isn't too dark, so you don't have Sirius overshining or outshining its companion. That's the best time to view it, and I've done it in like a 12-inch Dob. The 20-inch that I had really took care of it, but it's not so much about aperture, it's just seeing. And you want to make sure you've got about 200 magnification on your telescope to really pop it out of the field there. So that's how I would observe Sirius, if you want to go out and check that out while we still have Sirius visible in the sky at this point. Let's go further down the list. That pretty much wraps up the wintertime objects. So we did Orion, we did the Horsehead, we did Abell 12, we did Comet Atlas, the 37 cluster, we did Hubble's Variable Nebula, and we just did M46, and this is Thor's helmet, NGC 2359 in Canis Majoris. And that really wraps up a lot of, and we did the Rosette and a couple other special ones. So that really wraps up the wintertime objects. So we're kind of scraping at the bottom of the barrel for wintertime objects at this point, because we are in spring now. So we're going to stop this, and now we're going to flip to the opposite side of the sky, and we're going to go extragalactic at this point. All the stuff that we've been looking at tonight so far has been in our galaxy. But now with spring coming up, there's a lot of galaxies that come up, and that's just because of where we sit in our galaxy and how we're positioned. Is during springtime we're looking out away from, so if you can imagine our galaxy is kind of like a pancake. We're looking across the plane of the pancake. During the summertime we're looking towards the center. During the winter we're looking outward along that plane. Well, in the springtime we're looking away, out and off the plane, out into extragalactic space where all the galaxies lie. And that's what we're going to go check out now, is some of those galaxies. So let's pick their first one, and this one's almost straight overhead at this moment. And this is a really, really easy galaxy to see. And it's one that you can actually do in a pair of binoculars if you've got a half decent backyard that's not too dark. Or even if it's not too bright, you can check this one out. So let me flip the camera. And we don't need our fancy filter anymore. We can go back to our visual filter. Now this galaxy that we're on right now is known as M81 and is one of the easiest galaxies to see in the entire night sky. And you can easily pull this one out in a small pair of binoculars, like 40 or 50 millimeter. A little telescope will do this, and the bigger the telescope, the better the view, obviously. But this is M81. This is part of the Ursa Major galaxy group. This is one of the largest ones in the group, and it's a spiral galaxy, so you can see some of the spiral arms coming out. The image is going to be a fair bit sharper because we're not looking low anymore. We're looking almost straight up, which is the happiest part of the sky for the telescope. This particular galaxy is 12 million light years away. So the light we're seeing from this galaxy left 12 million years ago, and we're just now starting to see it. So it's been going for a while. And then distance-wise, across the galaxy, you're looking at somewhere about 90,000 light years edge to edge. So that is M81. And this was originally discovered in 1774 by M. Bode. Bode. This is also known as Bodes Nebula, even though it's not a nebula. We know better now with our observation capabilities that it is in fact a galaxy, but back in 1774 it looked like a fuzzy. It still does look like a fuzzy. So it's but it is a galaxy, but it's still known as Bodes Nebula. So this was later observed by Charles Messier in 1781, where it was cataloged and officially given M81 as its classification. This belongs to the local group, which means the same group that our galaxy is a part of. This one is too. Excuse me. And this one holds about 250 billion stars and has a massive black hole in the middle of it. So a lot of activity down in there. Let me see if I can stretch some of this to bring out the arms a little bit. Right in the center, way down in there, is a supermassive black hole. And there's also estimated to be about 210 globular clusters. So those tight balls of stars, those are down in there as well. So this is quite a galaxy, and this particular galaxy, M81, Messier 81, has a lot of pull on the nearby galaxies that are in the field there. And there's another one not too far away from this one, and we're going to try to get it real quick. Let me see if we can center up on it and its nearby friend here. So get the telescope to slew over here. Just a small scoot. And back to the camera. So there's actually two galaxies not far from each other. Of course, we have M81, and then the second one is M82. I know, who would have thought? Two galaxies right next to each other with only one decimal change, or one numeral change. So yes, M81 and M82. So here's the two galaxies together. M81 is on the right, M82 on the left. M82 is known as the Cigar Galaxy because it looks like a cigar. And M81 is still the spiral that we were just looking at there on the right-hand side. Now, some cool things about this. So obviously M81 has a lot of pull on M82 on the left there. These are both about 12 million light years away. M81 over here, 90,000 light years in diameter. M82 about 37,000 light years. Both of these discovered by the same gentleman in 1774. Now, over here, this is what's known as a spiral galaxy. M81 is a spiral, so you can see the spiral arms in there. It's pretty obvious. And if the weather was a little bit more calm tonight, we could definitely pull those out. But M82 is what's known as an irregular galaxy. And it's kind of been spun around a little bit because it's had interactions with M81 from different over the years. And this particular one, due to that, you see a lot of this dark region, and it has a lot of what's called starburst going on in it, or star formation is what starburst means, and it's really heavily active with that because of the tidal streams and stuff between the two galaxies having interacted with each other. Now, M82 is actually receding from us as well at about 125 miles per second. And we've also been able to check into this using special telescopes in space to observe in the infrared. And there is some spiral arms with M81, so they think a lot of this used to be a spiral, and then when the two acted together, it kind of threw some things off inside the M82 galaxy. So pretty interesting stuff. And these two are both visible in small optics from a backyard. So if you've got a little telescope, pop it out, use your star map on your phone and go hunt them down. This is M81, M82. If you know where you're looking, a pair of binoculars will do it too, especially in darker skies. But here in town, you should be able to at least get the little fuzzies in there. So those are M81 and M82, two of the most observed galaxies here in the northern hemisphere. So pretty neat stuff. Now we're going to stay in the same region of the sky, but we're going to flip on to another galaxy here. John, I've had different measurements on M81 and M82. I've heard they're about 130,000 light years apart from each other. It seems really close. But I'd have to look into that. But at the moment, what I've seen is about 130,000 light years between M81 and M82, roughly. So that's kind of where we're at with that one. Let's have the telescope slew to the next target real quick. Let me get a drink while we're at it. Now the next target, of course, is another spiral galaxy. Over the next couple weeks when we do these, be a lot of galaxies because spring is galaxy season. So if you're into galaxies, this is the time to get out and view. The only problem is you generally need dark skies to do it. So getting away from the city lights with no moon is the best way to get going on galaxies. Or just join us here on Starstream and we'll just do it live from home. And just sick the camera off for it. And it'll really make it a lot easier to see it. So this next galaxy is known as M101. This is a very popular galaxy, and it's big. About 170,000 light years across, about 25 million light years away. So we're twice the distance than the last two galaxies. This was originally discovered in 1781 by Pierre Messier, and Pierre was actually the assistant for Charles Messier. So this is M101, or Messier 101, 25 million light years away, 170,000 light years edge to edge. And this is known as a face-on spiral. It's relatively faint. Even for a Messier, this one's a little more of a challenge compared to the last two. Good skies and a large telescope about 8-inch or bigger in diameter will really help you observe this. And obviously the bigger the telescope, the more resolution you can get to catch it. But this is a face-on spiral because we're literally looking, you can imagine a coin, you're looking face on. That's what we're looking at. And that's what you can start to see here as the camera starts to bring in more light. If you look real close here, let me kind of bring this in a little bit. You're going to see some of these knots, like right here and over here and right there and over here. I think this one's one too, way out there. These are what's called H2 regions. And these are star-forming regions. They're basically nebulas in that galaxy where baby stars are being made. Much like Orion, they're emission nebulas, essentially, and we can see them. So they must be massive to be able to see the glow of these things 25 million light years away, to be able to see the glow of all that, there must be a ton of stuff going on in there. And this is because of how big it is and the arms. There's a ton of stars in this galaxy. There's about 1 trillion stars in M101. So it's crazy big galaxy. Twice the diameter of our own Milky Way. So this is a huge galaxy. Messier 101, also known as the Pinwheel. If you ever remember being kids and having the pinwheels, you blow into them. That is M101, the Pinwheel Galaxy, and this is invisible light. So this is how it would appear to the naked eye. Probably in a larger telescope. You can start to see some of the dust bands starting to come out. If we really wanted a good picture on this, we'd really have to sit on this for a while. Much longer than we are now. This is only about 2 minutes worth of exposure time at the moment. To get a really good picture, you'd be hours sitting on it. So something to definitely check out and explore. But this is M101, the Pinwheel Galaxy, a face-on spiral in Ursa Major, the Big Dipper. Kind of down towards the handle is where that would actually be, nearly overhead at the moment. Let's see. Next target. The next target here is another nebula, actually. Probably the last nebula for the evening, actually. So we're going to get that over to that position real quick. We're going to send the telescope over there. Jared, how do you counteract the light pollution when shooting galaxies? Won't filters cut out? Yeah, so if you're shooting, the question is, how do you counteract the light pollution when shooting galaxies in town? I use a light pollution filter, and I just have the camera expose and just keep going and pounding it with as much light as you can. So that's what I do about that. So there's not much to it other than just letting the exposure time take care of it. And that's really all you can do about it. It's galaxies are kind of a difficult one where you either need dark skies or you just need to dig into it and hope for the best. The narrowband filters are not effective on most galaxies, and if they are, you're only getting certain chunks like those hydrogen regions we just saw in M101. M31, M13, and M92, while up, are blocked by the house, so that won't be happening tonight. So we're on our next target. It's going to be a ghostly little gray thing right in the middle, and I'll pop up our square again. So right in the center here is M97. This is a planetary nebula up in the constellation of Ursa Major, the Big Dipper, also known as the Owl Nebula. This is 2,000 light years away, so a bit closer than what we were looking at earlier. And it should be a lot sharper. It's really windy outside, so it's kind of throwing some stuff around. Hopefully in the future things will be sharper. And it gets its name by, you can kind of see right now these two dark gray insets right here. That is where it gets its name, the Owl Nebula. So it's round. It kind of looks like an owl face. This is a planetary nebula, and this is in hydrogen, though the nebula is mostly blue. So for this case, we're actually going to switch over to our oxygen 3 filter. And the oxygen 3 filter is actually letting through double ionized oxygen, or the light emitted by double ionized oxygen. So if you keep an eye out here, what's going to happen is, now this is hydrogen, and when the camera downloads it here in a second, you'll see what it looks like in oxygen. It should shift. There we go. So This particular nebula has a lot of oxygen in it. So you can actually see that we got a lot more detail and signal in there with the oxygen filter in place. So you can really see the difference by using different filters to isolate certain phenomena. You can explore different things. So we saw how hydrogen, it was there, but if you're shooting planetary nebulas, planetaries have a lot of oxygen, double ionized oxygen in them. And that really, really comes out much better if you've got the oxygen 3 filter. So that is the O3 filter. And we're pulling out a lot of the detail. You can really see those dark regions in there where it makes it a lot easier to see where it gets its name, the Owl Nebula. So that is the Owl Nebula. That's the last nebula for tonight. All the nebulas in the springtime are really faint, really difficult to see. So this is kind of one of the few that are up this time of year. But that is the Owl Nebula, and this is in the oxygen 3, so almost the blue wavelength, of almost in the blue part of the spectrum, like turquoise, is roughly where this color, this filter is letting light through. It's kind of like a turquoise color. So we're going to stop that and get ready to flip to our next target on that. Now, the next target is one of the most, or let's actually do the next door neighbor real quick. So not too far from the Owl Nebula is another galaxy. And if you've got a wide enough field of view on your telescope, and we don't tonight to get them both, is M108, Messier 108, also known as the Surfboard Galaxy. I don't name these things. I'm just telling you what they're called. We're going to flip back to our visible filter and check out the Surfboard Galaxy M108, not very far from M97, the Owl Nebula. And this is also an Ursa Major. This is what's called a barred spiral galaxy. It's 32 million light years away, 37,000 light years edge to edge. It was originally discovered in 1781, but it was never accurately documented. Oh, we got a satellite right there. That's a satellite, and as our picture goes, you'll actually see it move in the shot. So we're going to go from here, and it's actually going to move through the frame there. So our next one that comes up, it should streak even further through the shot, so you can see it. So yep, there it goes. So it's making its way out of the streak right here. This is M108, Surfboard Galaxy, 32 million light years away, 37,000 light years edge to edge. There's over 400 billion stars in it. It was discovered 3 days after M97, but unfortunately, Pierre Méchain never documented it officially. It was actually introduced to the Messier catalog back in 1953. So it did take some time for it to officially become a thing in the Messier catalog. This has a supermassive black hole at the center of it. It's estimated to be about 24 million times the mass of the sun. So it's a big thing. That's why it's nice that it's 32 million light years away. And it's one of the largest galaxies in the Ursa Major cluster of galaxies. So that is M108, the Surfboard Galaxy. It's not too far from M97, and with a big enough field of view, you can easily capture both of them together. So that is M108. The next one that we're going to be doing is one of my favorite galaxies, and most people have seen a picture of this galaxy, but maybe have not had the chance to really see it in person. If you ever get a chance to go to a dark sky and a big telescope and you have a chance to view this galaxy, it is phenomenal to actually see it in person. But the camera is going to do a nice job on it too. So let's dig into that and check it out. We've only got a few more targets left, and then we're going to wrap this evening up. But I appreciate everyone hanging out tonight. And if you've got any final requests, we can throw those in the queue here. Just a couple more objects, and then we will finish up tonight. So this is one of my favorite galaxies. This is the Whirlpool Galaxy, and it looks like a whirlpool. It's actually two galaxies together. So M51 is the main piece right here, and its little companion that we see over on the side is known as NGC excuse me, NGC 5195 is the little companion over here. Now NGC 5195 is actually a little bit behind NGC 51, or I'm sorry, Messier 51. Hubble observations of the galaxy actually found that the smaller galaxy, while they are touching with each other with tidal streams together, they are affecting each other's shapes. They're not actually running into each other. They're just very, very close to each other. This is about 31 million light years away from the Earth, about 111,000 light years edge to edge, and was originally discovered in 1773 by Charles Messier. M51 is the catalog. This galaxy is pretty cool because there's a lot of compression of hydrogen actually occurring out here in the outer arms. And maybe we can actually see that if we stop this real quick and I can flip my filter. We can see if we can see some of the hydrogen sections of this galaxy. Out on the outer arms here, the arms are actually compressing hydrogen and making star-forming regions, H2 regions, and we can actually see that when we use hydrogen alpha filters. So if we flip from the visible to our hydrogen filter, we're going to try to isolate some of those sections, and it's going to be really faint. So we're going to give it a go. If it doesn't work, then that's okay. Yeah, that's a little faint. So we're going to stop that. We really need to sit on a target for a long time to really bring out some of these details. So let's flip to the blue, because there's a lot of blue in this galaxy. We're going to flip to the blue filter. Now when I say flip to the, we've been on the green filter and we have a red filter and we have a blue filter. It is in fact isolating those colors of light in the spectrum, but because it's a black and white camera, you're not going to see it. But that's how we basically compose a color picture with a black and white camera, as you use a red, green, blue, and then finally you put those all together and assign the colors at the end of when you're done processing. So this is M51, the Whirlpool Galaxy. This is in Canis Major, which is not far from the edge of the Big Dipper. And this is M51, the Whirlpool Galaxy, and its companion NGC 5195. Awesome galaxy to see in a telescope if you have the chance, especially if you get out to a dark sky and it's dark with a big telescope. It looks very much like what you're seeing right now. Just the fact that you get to see it with your own eyes is really, really neat. So that is M51, a Whirlpool. So we're going to come up to our next target. We've only got 3 more on the list. And the next one, of course, is, you guessed it, another galaxy. We're going to fling over there. We're not too far from where we're on already. So let's get the camera back on. And we're going to flip back to our green filter, get the pictures going. And let me get my square out of the way so it's not covering everybody. And so what we're on right now, this is another galaxy called M106. There's no special name for this one either, just M106, or Messier 106. This is it right there. There's some other galaxies in this field, so you're going to see a bunch of little fuzzies in the background. Tends to happen with stuff like this. This is 24 million light years away, 122,000 light years in diameter, so this is big. This again was found by Charles Messier's assistant, Pierre Machon, in 1781. And this is another spiral galaxy. You can kind of see some of the spiral arms. But what we can't see here, the galaxy actually has these faint red ghostly arms that come out of the center there. And they're actually not stars. The reason why all these outer arms generally glow is because they're stars. But if you look at the Hubble image, you'll see all of that. You'll see some ghostly red coming out of there as well. And those are hot gases. And what people assume is that that is coming from this supermassive black hole at the center of the galaxy, really churning a lot of detail and material in there really violently because of the galaxy or the black hole spinning stuff all around. And this galaxy is actually moving away from us. It's receding at 330 miles per second. So it's moving away from us at quite a speed. So this is M106 in Canis Major. Really cool galaxy. It's got some other companions down here below that you can also check out in other exposures and other images online. And maybe we'll actually do a follow-up picture on this in the future. And, definitely check it out. Just to give you guys an idea, right down here, this is NGC 4248. That's another galaxy. And then just below that, kind of down in this section, this is NGC 4232. And then there's a collection of other galaxies, a bunch of little dim stuff in here. If we sat there for a while, you'd be able to see all kinds of stuff. So this is M106 in Canis Major. So we've got two more objects. The last one, the next one is not a galaxy actually, and we did this 2 weeks ago, but this is going to shake it up a little bit. This is a globular cluster, and it's a really stunning globular cluster called M3, and this is a collection of over 500,000 stars all grouped together. And it's just really a beautiful thing to actually check out, both visually and photographically. And this is 34,000 light years away from the Earth, 174 light years in diameter. So edge to edge, we're talking 174 light years across. And this is M3, the third addition to the Messier catalog. And this is what a lot of the bright ones really look like. As we move into summer, you'll get M3, M4, M13 is obviously super popular, the biggest of all of the regularly visible ones here in the northern hemisphere. There's an even bigger one called Omega Centauri, but it's very, very difficult to see here in the northern hemisphere unless you're really far south. So this is M3. This is a globular cluster, a very dense ball of stars. It's about 8 billion years old. And these clusters form a halo around the Milky Way core. And this particular one is 500,000 stars. So it's one of the larger ones. And this kind of issues the coming of the globular clusters for summertime. So M3 is normally one of the first ones that become visible in the sky. This is about 34,000 light years away from the Earth, so it's quite a cluster of stars to really check out, and really looks great in a wide variety of telescopes. So the bigger you get, the more punch you can see, and this one's really quite neat. You don't need a big telescope, but you know, like a 3-inch telescope, even a pair of binoculars, you should be able to see it. But yeah, the bigger the telescope at that point, the more punch you're gonna get, and the more you can see. So this is M3. It looks like a big pile of sugar, all piled on top on black tablecloth, but very, very cool object to view in the nighttime sky. So, all right, we're gonna head over to our last target of the night. Normally these star streams are about an hour and a half. That seems to be like a good amount of time. If we run over a little bit due to requests and stuff like that, so we're gonna hit the last one here. We'll be leaving M3, and we're gonna go check out the last set of objects for the night, unless we get another request or two. If you have any questions, you can throw it over in the live chat. If you have any final requests, throw it over there in the live chat. I'll see what I can do for it. But the next set is actually 3 in 1. So 3 objects in one field of view. This is a very popular one, and is one that we'll probably be covering over the next several episodes, because it's just that part of the season. So we've moved over to the constellation Leo the Lion, which is really high overhead right now. So these should be relatively sharp and easy to see. And this is known as the Leo Triplet. The Leo Triplet is composed of 3 different galaxies. Wait for the camera. There we go. 3 different galaxies. And 2 of them are part of the Messier catalog. The other one is part of the NGC catalog. And we're gonna, let me just double check which one is which on these. So what we're looking at now is the Leo Triplet. And the Leo Triplet is basically M65, Messier 65, Messier 66, which is the spiral up here, and NGC 3628 over here. And they're actually all pulling on each other to some extent. M66 is doing most of the work. And there's actually a large stream, tidal stream, which is basically like a chain of stars coming off NGC 3628 right here, but it's very, very faint and hard to see. Just to give you an idea, M66, excuse me, right up here is 37 million light years away. NGC 3628 is 35 million light years away, and then M65 is 42 million light years away. These 2 right here, M66 and M65, were originally discovered by Charles Messier in 1780. And then the NGC 3628 over here was 1784 by William Herschel. Now these are all pulling on each other. They're kind of distorting each other. There's a nice spiral there, but it is being pulled apart a little bit. And then M66 up here is also kind of being pulled apart as they all kind of work around each other up there. So, but this is the Leo Triplet. This is a fun one to see. You don't really need a whole lot of aperture to see these. And this guy over here is more difficult, but the other 2 can be easily seen. In just slightly darker skies, you can see all of that. So it's definitely a cool object to go out and view, because you're basically getting 3 in 1 at this point. But that is the Leo Triplet. And at this point, that kind of rounds out everything I've got for you guys this evening. So thanks all for joining in tonight. That is Starstream. And if you want to check out when our next episodes are going to be, you can go to focusastro.org and check out our website to see when we're going to have future Starstream episodes. We do these every 2 weeks, so every other Friday, just so we have enough time to let the sky rotate up into the evening. And we're going to try to do something different every time. But you can always head over to Focus Astronomy / Starstream to see our next episodes. Of course, we have tonight, the 17th. Next one will be May 1st. We're going to be doing a lot of the galaxies and stuff we're seeing now, but we're also going to focus on the moon, and because it will be up that night. And then, of course, on May 15th, we'll be heavily into galaxy season and really diving into some really far off stuff. So that again is Starstream by Focus Astronomy. If you want to know about any of our other stuff, you can head to our website and check out stuff under events or all of our different offerings. But we definitely appreciate you checking in tonight. Thanks for watching another episode of Starstream, and I hope you all have a great rest of your weekend. If you do like these videos and you want to see more of them and you want to know when we're going to do more of them, you can go ahead and subscribe to the Focus Astronomy YouTube channel. And then when these become active, you'll be able to check them out and be aware of when they're going on. So thank you very much. I hope you all stay safe and healthy, and we will catch you on the next episode. Thank you very much and have a great evening.